Now we are going to derive the voltage and current, the relationship between voltage and current for this PN junction diode. So this is the lengthy derivation, but before going into this derivation, let me tell you something about how this came into the picture. We know for normal equilibrium case, this is my PN junction diode, this is my junction. We usually what we do dope this P side bit more than the N side. Remember, as I told earlier, that we do doping more P side than N side. This is for practical purposes. That's why our depletion region depend more towards this N side, towards the less doping side. This region is less doped. This region is more doped. More doped means more number of impurity added. So to maintain this neutrality, our depletion width for this N side goes more deep. So this was for the equilibrium case. Now we are interested to find the current. In equilibrium there is no current. So we are interested to find the current. The current will apply when we will apply the voltage. Now let's take the case I am applying a positive voltage over here, negative voltage over here. That is, I am applying forward bias to this PN junction. Now what happened? We know, as we read before, that applying positive forward bias means this width will become less. That means I am just to removing these charges, I am just showing how this width is becoming less. So my width, it become like that. Before it was bit lengthy, but because of this positive voltage forward bias, the width become less. Now what happened? This is negative charge, this is positive charge. The holes which are the majority carrier over here, the holes, and the electron which are the majority carrier over here. Majority means there are plenty number of electron present over here. There are plenty number of holes present over here. So as the depletion width is less, there is less barrier, less resistance. So electrons start diffuse through this hole to that side. Electrons start diffuse. If electron will start diffuse to that side, what will happen? Here is one electron, here is one hole. Hole start diffuse. This hole start to recombine with this electron. So it will disappear. This electron hole will recombine. Then what happen? If as the number of holes will goes to the N side, maximum number of electron, that is a majority charge carrier, they will disappear. But this PN junction should be maintain neutrality. For that, what we have to do? We have to supply electron. We have to inject electron so that it should maintain a neutrality. As the number of electron coming, holes coming this side, equaling this number of electron to removing the recombining. So means electron number is decreasing. So to maintain that neutrality, we are injecting electron this side. Similar case. As these holes, these are flowing to that side, diffusing towards N side. This number of holes present over here, it is decreasing. So to maintain this, what we should do? We should inject hole to this side. But generally we can't inject a hole because hole is nothing but opposite of electron. So what we are going to do? We are going to draw electron. Similar way that injecting holes means drawing electron. It means the number of electron it will come out, the same number of holes it is going out inside. So the number of holes that is going to inside and recombining with the electron, again the same number of holes that are coming in, means it is maintaining neutrality. Similarly, as I told before, this side also maintaining that electron neutrality. How? As the number of holes recombining with this electron number is decreasing. So injecting maximum number of electron means it is again maintaining neutrality. Similarly, then again to cross this barrier, this electron will start to diffuse this side. This electron start to diffuse this side. Then what happen? Number of electron in this side decreases again. To supply that, what we are again going to inject electron to this. It means the number of electron that goes to P side just for through diffusion and recombine with each electron, to maintain this neutrality of this side, again we are injecting electron. So number of electron injecting is same as the number of electron that are going out this side and recombining, to maintain neutrality only. Okay. Now as these electrons are coming this side, these holes, they are disappearing. The holes present over here, these holes are disappearing by recombination. It means at the P side, the concentration of holes, it is decreasing. So how to maintain neutrality? Again we have to inject holes, then only it will maintain neutrality. But we can't inject holes this side. It means we are going to take the electron. It means in that same way I am saying injecting the holes. Injecting holes or taking electron, both are same. Now you can see number of electron that I am giving at this side is the same number of electron that I am taking outside. That means it is maintaining a electrical neutrality. Okay. Now this process is over. We are injecting. So injecting electron means nothing but we are supplying current. So this, because of current, this electron are coming. Okay. So this was the outside concept. Now what happened? Here holes are the minority charge carrier. Minority charge carrier, less number of holes at this side. Here electrons are the minority charge carrier. So the holes which are present over here can be represented as Pn naught. Pn means number of holes at n type material at equilibrium. That those are the minority charge carrier. These are the minority charge carrier. These holes at this side are the minority charge carrier. They are represented by Pn naught. Similarly, the electron over this side, these are the minority charge carrier. They will be, since this is p side, means it will represent Np naught. So n is equal to number of electron present at p side at equilibrium. These are the minority charge carrier. These are represented by Pn naught and Np naught, which was already present before there, before injecting these holes. It was over before there. Now at equilibrium condition it was there. Now as you supplied voltage, positive negative, the holes start diffuse. So maximum, there are lots of holes, lots of electron present here. So holes start diffuse. So holes start diffuse from this to this, in this way. In this way, holes start diffuse. So as holes start diffuse, number of holes that are present here, it is coming this side. So slowly it is what are you doing? It is recombining with the electron present over here and moving forward, again recombining and moving forward. So as the concentration here, hole is high, here is low, holes start diffuse. Similarly, here electron concentration is high, so electron start diffuse this side. Now take the case of hole. Hole start diffuse, so it will recombine first stage, second stage, third stage. Slowly it is moving. At end, what we will get? That there is no less number of minority, the excess electron. This excess hole towards this end, towards the length, this up to this, when a hole will reach there, it will less. It means at this side there are excess of electrons. So you can see from here, it was the number of minority charge carrier present before. So this is the Pn naught which was present before. Now this holes start diffuse to this side. So at starting near the junction, you can see this is the junction, this is the Xn, this is the Xn, this is our minus Xp, this is our minus Xp, this is Xn. So near the Xn you can see maximum number of holes are there. So as we are moving towards this length, what happened? Our excess carrier, these are the excess carrier, these holes at this side are the excess carrier, so they are decreasing exponentially. Similarly, before there was some Np naught of number of electron, that is a minority carrier present over here. That is the Np naught whose value is less. As the electrons start coming this side, diffusing this side near the junction, that this junction, a minus Xp. At minus Xp, the number of coming electron to this side is high. So as they will move, what will happen? They will recombine with the holes present over here, and slowly it is decreasing exponentially. Got it? Why this Np naught is less and Pn naught is high? I told earlier that number of, for P side, what is there? It is the number of acceptor ion, and for N side, that is the number of donor ion. What I did? At starting I made P plus, means I made P with a more doping. More doping means Na is high. Doping means adding this Na. So Na is high. So Na, where it will occur? Na will occur over here. This is Na. As Na will high, my Np naught will less, because Np naught is nothing but Ni square upon Na. Remember that diagram I did before. Now, my Nd is less. So suppose this is Na. So this is my Nd. So this is Nd means my Pn naught, which will be Ni square upon Nd. So this will be bit high. Denominator Ni square upon Nd. Denominator less means this overall value is high, so it is bit high than this value. That's why my Np naught is bit low, Pn naught is bit high, because my Na value is high and Nd is low. I did P side with more doping, that's why Na value is high. Now because of this is the exponentially decrease. Now the concept came from continuity equation, that according to the continuity equation we are going to derive the current how much current that is flowing over here. So the continuity equation says as the time passes, at time the change with the number of excess electron or excess hole, that is equal to 0. That is the continuity equation saying. So that I can write in place of this dpn, I can write dp into d square pn upon dx square plus gp minus rp, that is number of generation of holes, number of recombination of holes. So how much that is generating at this side minus how much that is recombining that side, taking the difference, adding this value with a partial derivative, that is equal to 0. Okay, for that you have to remember this continuity equation, for that you have to understand what is continuity equation. So now what will happen? Now I am just solving. So dp square pn upon dx square is nothing but I am taking this value opposite side. So gp minus rp will become minus gp rp, that is equal to rp minus gp. dp was multiplied over here, it will become divided over here. So this is nothing but rate, generation rate or reproduction rate. So the reproduction rate, so do the rate. Rate means charge carrier upon time. So this tau p is the lifetime of this minority hole at n side. This tau p is the lifetime, that for how long time those holes are going to stay in this n side, that is the tau p. So my rp, that is generation rate. Rate means what does mean a velocity? Velocity is nothing but rate. So some distance upon time, that is the same, that is some charge carrier concentration upon time. So this is pn minus pn naught. Okay, now this is pn. So if I take the derivative of pn minus pn naught, that will be same as pn. So it will not change any value. Just to make this equality, to make a quadratic equation, I am doing pn minus pn naught. Just in place of pn I am writing pn minus pn naught. So everything is same. d square upon pn minus pn naught upon dx square equal to pn minus pn naught tau p into dp. So this is a quadratic equation. You see dou square y upon dou x square plus some y by some constant, something is there like this form. So what is the solution for this type of quadratic equation? So y is nothing but c e power minus x upon lp. So what is this lp? This lp is called diffusion length. Diffusion length of holes. Means for how long this holes going to diffuse, that is the diffusion length. Similarly for n side, what will occur? That ln, here you can see one ln is there. So ln is the number for that much length the electrons are going to diffuse. So here this is the xp. Okay, at our junction we know this formula, that pn naught is nothing but pp naught e power minus vt by vt, v naught upon vt. Junction means I am talking about this junction or this center junction. I am talking about this center junction. You can see at center, this here is np naught, here is pn naught. So there might be one relation like that. So for that case, that center case, I am writing this relation, that is junction law. For at junction, my npn naught, which is nothing but this pn naught, which is nothing but pp naught. What is pp naught? That is the number of holes present at p side at equilibrium case into e times minus vt by v naught upon vt. So my pp, normally pp is nothing but pn is nothing but pp times e power v naught. This is a normal case, only equilibrium case, when there was no biasing. It was the case for no biasing. Now I am applying a voltage, that is a voltage v plus minus v. So if v will applied, then my pn naught, it is nothing but pn. pp naught will become pp. So pp into e power v naught will change to v naught minus v, because I am applying forward bias. So it was before v naught, as I said. So v naught, electric field was moving this side. Now as I applied my forward bias, my electric field will move this side. So this is v naught, this is vr. So my net electric field will be this side, whose value is nothing but v naught minus v forward bias. This is v forward bias. So you remember this, I told before, v naught minus vf. So I am writing here v only. So v naught minus v. Just in place of v naught I am putting v naught minus v. Okay. Okay. At the junction, my pp, which is nothing but my pp naught into e power minus v naught minus v upon vt. Now come over here. From here just I am writing. So pn minus pn naught. So this is my pn and this is my pn naught. So I have to find this pn minus pn naught. This is my equation actually. This is my, I have to, what I need? I need a current. Current is nothing but, I can, from where I can find this current, is equal to j into a. So what is j? J is nothing but q times dp dou px upon dx, like this. So that's why I am finding this p. x. Then only I can take the derivative and then multiply q into dp. I can find j, and from j multiply with area I can find I. That's why I am finding this Pn. Now see, I found this is Pn. I wrote Pn. My Pn naught is nothing but Pn naught. So what I did, just from these two value I wrote it here. So took Pn, Pp naught common, and e power minus Vt, V naught upon Vt, e power minus V naught upon Vt. It is taken common outside. So what will remain? Here remain e power minus plus V by Vt. If I'll open this one, it will become e power minus V naught upon Vt into e power plus V by Vt. So that's why e power plus V by Vt taken common. And from here only one will left. Now I will compare my this Pn minus Pn naught with this one. So you see e power V by Vt minus 1, e power here Pn minus Pn naught, here this is. So if I will compare these two, this is my Pn minus Pn naught, this is my Pn minus Pn naught. So this RHS is equal to this RHS. So if I will compare, C e power minus x upon Lp is nothing but this value. So you can see this Pp naught e power minus V naught upon Vt can be written as Pn naught. This Pp naught e power minus Vn by Vt can be written as Pn naught. So I wrote it Pn naught. So I have to find this value of C. So C is nothing but Pn naught e power V by Vt minus 1. This e power minus x by Lp will taken this side. It will become e power x by Lp. And we are finding this value of C at the junction. So at the junction means at x. What is the value? That is equal to xn. So I am writing xn. If I take this value, what will happen by C? C is nothing but e power minus xp upon Lp. So here it is plus xn upon Ln. So in place of C I will put this value. So what will be Pn minus Pn naught? Is nothing but this is the C value. I wrote directly over here. Pn naught e power V minus Vt minus 1 e power xn upon Lp. E power xn upon Lp. Multiplied by e power minus x by Lp. E power minus x by Lp. This is my Pn minus Pn naught. So what I will do? I have to find my Pn. So I am taking this Pn naught value this side. So it will become add over here. So Pn naught plus all the value that is over there, that will be the same. Okay. So what will be Pn? So Pn is nothing but Pn naught plus Pn naught times e power V by Vt minus 1. So if I will combine these two, you can see this is e power minus x by Lp. This is e power plus xn by Lp. So e power minus taking common x minus xn by Lp. If I will open this, it will become e power minus x by Lp. E power minus plus xn by Lp. That is the same. The same way that I found Pn, I can write in place of Pn, I have to write Np. Then again I will do the same process, all same, just in place of xn, I will write minus xp. So I will get my Pn nothing but that is equal to, Np is nothing but Np naught. Same, just in place of Pn I am putting Np. Np naught e power V by Vt minus 1. Just in place of xn, what I am going to write? I am going to write plus xp. Here it is plus xp. Sorry, it is minus xp. So what will it become? It will become x plus xp. It was only minus x plus xp, minus xn, plus xn. Now for n case, second case, what will it become? Plus x and minus xp. So it will become x plus xp. The same way by ln. Here it was the diffusion length for holes at n side. That for how long this? So for n side, for this p side, what it will become? Ln. That is the number of length for the holes, diffusion length for holes. That is the L into came into picture. Okay. Now there are this is we found this Pn and Np. Now we are going to find this J. J means this Q minus Q times dP times d of Pn upon dx 1j p. Again 1j n, which is nothing but Q dn d by dx upon np. Np of x. This is Pn of x. Now we are interested to find the Jp. Jp is nothing but this minus q dp derivative of this one. Okay. So this is a constant term Pn naught. You can see this is a constant value. So derivative of constant, it will remain 0. And in this part only this term is there which is a function of x. Only this term which is function. So the rest are the constant. So Pn naught e power V by Vt minus 1 will be a constant. It will taken outside. Minus q dp was before there. So derivative of e power x, e power minus x, that is equal to e power minus x into this, because of this minus and some term is there. It is nothing but derivative minus e power x by a. It is in this form. So what is the d by dx of e power minus x by a? Is nothing but e power minus x by a into minus 1 by a. So remember the formula for derivation. So this is e power minus x by into 1 by a. So in place of a, it is LP is there. So that's why I wrote minus 1 by LP according to this. So this minus combined to give me a plus q dp. This LP came over here. So this is Pn naught e power minus b by bt minus 1 into e power this is there. Just tell me when this current will maximum. At this junction only. At this junction current will maximum for this n side, and at this junction the current will maximum for this p side. So that's why for Jp maximum, which is nothing but Jp when x equal to xn. So if I put in place of x equal to xn, this xn minus xn, it will become 0. So e power 0, that is nothing but 1. So this value will give me 1. This value will give me 1 when x equal to xn. Then what will become my Jp? Q dp upon Lp, Pn naught e power Vy minus Vt, same as that. Similarly, if I take the derivative of this one, similarly in place of just np, I am putting this value. So this is the constant derivative 0. This is the constant taken outside. So this is the derivative of e power x by a. Now it is e power x by a. So simply e power x by a into 1 upon a. No negative sign, no negative sign. So at the output what I will get? I get Jn at x equal to minus xp, because the J value will maximum at x equal to minus xp. That is the Jn value. So q dn upon ln. This n means hole, electron. This p means hole. This hole at n side. This is the electron current at p side. So q dn upon ln np naught e power v minus bt. So now my total current, which is nothing but the current that is moving because of this diffusion. So because of this diffusion, when I am applying this voltage, so what is my total current? Is nothing but A times summation of these two current density. So if you multiply this area, it will give me A Q, which is common. Q is common. So A Q taken outside. dP by LP. Pn naught the same that I wrote. Same. And e power V by Vt minus 1 is common. That is also taken outside. Now remember I told before that what is this Pn naught is nothing but concentration of holes at n side. So at n side, concentration of holes, these are the minority charge carrier. So concentration of holes at n side, that is at equilibrium, which is nothing but Ni square upon that, what is this, Nd, because the number of donor atom present over there. So in place of Pn naught, I can write Ni square upon Nd. Similarly, in place of Np naught, this is the concentration of electron at p side. So this side, what is present? Na is present. So Ni square upon Na. Ni square upon Na. So what I will do now, take Ni square as common over here. So Aq Ni square dp upon Lp Nd plus this dn upon ln Na. So this is my current. This is the total current. So this total current can be written as Is into e power V by Vt minus 1. This is our final derivation that we are going to know, that only for the current is nothing but Is into e power V by Vt minus 1. And for this derivation we did a lot of things, how to find this I value in terms of this. So what is my Is? So Is is nothing but Aq Ni square, this dp by Lp Nd plus dn by ln Na, and this is the part over here. Okay, this is our final derivation of current, and for in place of Is I am writing here. I told before in place of drift, that drift current I am showing Is. Why this is Is? You see, when I will apply a voltage, negative voltage means at reverse bias. Now take the condition of reverse bias. Reverse bias means my voltage is negative. So if this voltage V is negative and that V is some K times Vt, means 5, 10, 15 something times Vt, then what will be this value become? So e power V by Vt. So e power, that is negative some K Vt upon Vt. K Vt upon Vt. This Vt will cancel. So e power some negative value is nothing but it will give me a value 0. Means e power minus k is nothing but 1 upon e power k. So e power 2, e power 3, e power 4, this is the exponential increasing value. So 1 upon this exponent, this value is almost negligible to 0. Said be this negligible, that can be said to be 0. E power minus k is 0. So minus 1. So this total value will give me minus 1 value. So what will become my I? I is nothing but Is at reverse bias. At reverse bias, I is nothing but Is. That means this is the saturation current that I am getting at reverse bias. That's why the name came that saturation. Why? Because at some voltage, negative voltage, when this is some times k Vt, some power times Vt, then my I is nothing but minus Is. That is the, at reverse bias, this is the saturation current. And for forward bias, I will put positive V here, so Is into e power V by Vt minus 1. And we will see that what is the Vi characteristic for this diode. So this is the derivation for this current and voltage. You can see my current is nothing but a function of voltage. This is the voltage that I am giving either forward bias or reverse bias. This is the voltage and this is the current. Okay.